Hi guys, welcome back to my channel, and today I'm going to be talking about segment trees. So, a segment tree is a data structure that allows range queries and point updates on any operation where you can divide that operation into two parts. So, for example, minimum, maximum, sums, you can all divide those. Greatest common divisor, and some bit operations like XOR can all be used with the segment tree. There are expansions of the segment tree that allow you to have range updates, but those are more complicated, and I'll go over those in another video. Okay, so here we have an array, and let's say I want this seg tree to have max queries. So the idea behind this is to have a binary tree, and the very top will be for that operation over the entire array, and the two children of that will be the operation for the different sections of this array. So let's build out this tree. So the bottom nodes will be the actual array, and then above each of them, we will have basically this operation, which in this case is the maximum, to combine these two. So it will be 6 here, here it will be 7, and here it will be 6. So then on the next level, it will be same thing, so it'll be 7. And then for the final thing, it will also be a 7 at the top. So how does this work if we actually want to manipulate the array? If I want to query a range of the array, all I have to do is go down through this tree and find the topmost node that will gather as much of that range as possible. But there might be a possibility where the range is split in two. For example, if I want to query the range from 2 to 1, then there's no one node that stores this. So basically what you do is you go down here from 7 and you know, okay, it's on this side. It's on the left side of the tree, so we go down here. But this still is responsible for the 6 at the end, which we don't want. So then we have to keep track of the 7 over here and go down the 6. Now the 7 is good because it's doing this part of the range, but the 6 still has an extra part. So then we have to go down again and go to 2. Now this represents a full range. This way, we can very easily do queries on the range in log n of the time, because at most we're just traversing through this binary tree. Now, another important part of this is doing point updates. So the way to do a point update is, let's say I want to change this one into a 10. Well, essentially, I'm just bubbling up this change. So this will become a 10, and now the parent of this node might be changed. And in this case, it is. And then we check this one. This has also been changed because our new value is greater than this. And in this case, it will bubble all the way to the top. So this way, you can do both operations on a wide number of different types of queries, like minimum, maximum, GCD, and XOR operations. So now let's look at the code. This is the code, and it's doing the same thing that I was talking about. So the sum from A to N, it's the indices of the array. And because the array is being flattened in order to store the tree rather than being stored in the data structure, you have to add n to it. And by dividing both of these by 2, you're just getting the parent. So as you can see, you're going down the tree, and you continually adding these. In this case, this is a sum query, and at the end, you simply have to return it. Now, for adding to it, you have to do a similar thing with k, but as you can see, we're just dividing by 2 to go up to the parent, and you're just updating this range by adding to the value. So I hope this video is helpful. There's also another data structure called the fenwick tree that can also achieve this. I'll have that video linked below as well. And stay tuned for the video where I'll talk about the more complex uses of the seg tree where it gets even more useful. I hope you enjoy this. Thank you for watching, and subscribe if you liked the video.